Thank you all for joining this presentation. We appreciate the opportunity to speak to you today about the groundwater study we completed in Wasatch County. We also appreciate the efforts of the Wasatch County Health Department to manage their water quality resources, their water resources within their county. Throughout this study, we collected a large body of information over roughly 2 years. And unfortunately, we're not going to be able to get to every detail of that study today, but rather we're going to present more of a summary. But we would invite any questions or further conversation in the networking breaks. I want to introduce our team today, starting with Tracy Richardson, who's the Environmental Health Director for Wasatch County Health Department, and he's been the lead for this project. Myself, I'm Dave Epstein. I've been the project manager for SWCA Environmental Consultants. And the rest of our team from SWCA, Kayla Worthen, who's a water resources scientist, and Chris Garrett, who's a hydrogeologist. A little bit of background. Again, I mentioned Wasatch County Health Department has really taken the initiative and been forward-thinking and proactive in their management of their water resources. They haven't necessarily been reacting to problems, but rather considering that the county has been changing rapidly and growing rapidly, and wanting to make sure that they are doing what's necessary to manage, particularly the water quality of the groundwater resources. This historically agricultural county has grown at a rapid pace and has seen a lot of conversion of land uses out of agricultural uses and into residential and other land uses. And what's somewhat unique is that all of this development and growth is taking place on top of the county's drinking water resources, which are the Heber and Round Valley aquifers. In 1994, the health department commissioned a study that documented high quality groundwater, high quality water quality, and provided a body of research that led to a rule that limited septic growth to a certain density. And the health department put that into rule, and that has been the way that septic growth has been managed to the present time, when the county realized it's been a while since they looked at this at the water quality and wanted to take another look and update the understanding of hydrogeologic conditions and water quality, particularly as population growth has continued and is predicted to continue into the future. So the study area is the majority of Wasatch County, shown here in the red polygon. And we're showing specifically in the teal and orange polygons in the Heber and Round Valleys, the classified drinking water aquifers. The teal area being the pristine class 1A aquifer, and the more orange yellow polygon in the midway area, the class 2 aquifer, that has higher concentrations of total dissolved solids. Both of these aquifers are of drinking water quality. In our study, we took a phased approach and started with an initial phase that was focused on summarizing existing information, existing conditions, and identifying data gaps that would then be filled within the second phase, the phase 2 of the study, where we collected groundwater samples and had samples analyzed for water quality constituents. We did groundwater modeling of the aquifer and put together a mass balance model, and then ultimately used this new information to generate some recommendations for future management.
All right, this map shows the number and spatial distribution of septic tanks in the study area, and it illustrates that the majority of septic tanks overlie the principal drinking water aquifers. Moving out of our phase 1 review of existing information, we identified increasing residential growth and the increasing number of septic systems as areas of concern related to groundwater quality in Wasatch County. And other threats that we identified include the use of pesticides and herbicides, rising levels of nitrate that were identified from long-term trend analysis at USGS wells, leaking underground storage tanks, contaminants of emerging concern that have a mechanism to enter groundwater through septic systems. Contaminants of emerging concern are personal care products and pharmaceuticals, things like Tylenol, caffeine, and other household chemicals. And finally, the physical properties of the aquifers in Heber and Round Valley, because both aquifers are overlain by highly porous soils and lack a protective clay layer that prevents contaminants delivered at the surface from reaching the groundwater below. As part of the phase 1 investigation, we performed a spatial analysis of the study area, combining multiple data layers. Our goal was to create a GIS model to assess groundwater sensitivity and vulnerability to contamination. The groundwater model consisted of examining natural factors or physical properties that are favorable to the transport of contaminants delivered at the surface or subsurface to the aquifer. Groundwater vulnerability describes anthropogenic factors occurring in the study area that have potential to impact groundwater quality. So we turned the study area into a grid and summed all the scores of the input layers. In the resulting map, which is shown here, these scores are a gradient from green to red, with red indicating the areas more sensitive and more vulnerable to groundwater pollution. And we can see that the highly sensitive and vulnerable areas occur with the areas of highest population density that overlie the drinking water aquifers. And we use this model to inform our sample collection plan. Moving out of phase 1, we had 3 main objectives for phase 2 of the study, which are shown here. We wanted to collect new groundwater quality data, develop a model of the groundwater system, and develop recommendations for septic system development. And the figure on the right is a groundwater surface map, and we use that to better understand flow dynamics through the aquifer. This slide shows the various land uses in the study area and some specific pollutants of concern that we identified associated with those land uses. And it wasn't feasible for us to test for all parameters with drinking water or groundwater quality standards, so we identified a subset of parameters to test for. And in addition to testing for things like TDS, nitrate, and chloride, we also tested for other classes of compounds. Over the next few slides, we're going to show some of the results, sampling results, and for some of the key indicator parameters that we used to help zero in on some potential problem areas within the aquifer. So this map shows a map of the study area, the locations of the wells that we sampled, and the average TDS concentration of the 4 sample events conducted as part of the study over the course of 2 years. The color and size of the dot correspond to the concentration. And for reference, TDS is total dissolved solids. It's a useful parameter to measure to get an overall indication of water quality, and it's one of the primary parameters used in aquifer classification. Based on the 4 sampling events that were conducted, we can see that certain wells in some areas indicate localized hotspots with elevated levels of TDS compared to background. And these do represent points of concern in the aquifer. Some of the red dots near Midway are actually part of the class 2 aquifer where we expected to see higher TDS. This map shows the nitrate concentrations in the aquifer. Nitrate is the predominant form of nitrogen in groundwater, and it's often used in groundwater studies to examine the level of anthropogenic contamination, especially from septic systems. And in this map, we can see that similar to TDS, nitrate levels are relatively higher in the middle portion of the Heber Valley aquifer on the western and eastern margins. And finally, this map shows the chloride concentrations. The most common sources of elevated chloride levels in groundwater are road salting and discharge of water softeners to septic systems. We can see some of the same areas show up in all three maps. And I'd just like to point out that we tested for many other parameters in our sampling efforts, which are discussed in our report to the health department. And with very few exceptions, we did not detect volatile organic compounds, pesticides and herbicides, personal care products and pharmaceuticals, and heavy metals in the groundwater. All right, shifting gears a little bit to long-term trend analysis. One of the goals in the study was to examine how water quality conditions have changed over time, especially since the last major hydrologic study in the 90s. To do this, we used USGS data for a variety of water quality constituents and water levels and performed long-term trend analysis at individual wells and for the aquifer as a whole. This slide shows a couple graphs for nitrate, but again, in our report, we use the same technique for other parameters. The top figure shows time series plots at individual USGS wells in the Heber Valley aquifer. We conducted statistical tests for trend and determined that some wells show a significant increase over time. The bottom figure provides a way for us to visualize how nitrate concentrations are changing in the Heber Valley aquifer as a whole. And we examined all the available nitrate data from USGS wells in the Heber Valley aquifer and aggregated the data by year. We can see that nitrate is increasing in the aquifer as a whole, although the rate of increase is fairly slow. The takeaway from these figures is that nitrate concentrations are typically well below the drinking water standard of 10 milligrams per liter, except at a few localized hotspots. And again, other parameters are discussed in our report.
So the GIS model that Kayla discussed earlier helped inform our understanding of the overall basin, and then it helped focus the additional data collection efforts that we undertook. That done, our next step was to move forward with predicting nitrate impacts in the aquifer that could be caused by development, specifically the increased use of septic systems. So to accomplish this prediction, we joined together two other models, a computer model to simulate groundwater flow, then followed by a mathematical model to predict nitrate concentrations. I'll discuss the computer model first, and then Kayla will discuss the mathematical model. So there's one fundamental piece of information that we need to know before we can predict future nitrate concentrations in the aquifer. And that is how much water is flowing underground through the aquifer. So the method we chose to use in order to answer that question is to construct a groundwater model. The groundwater model is simply a computer simulation of the Heber Valley aquifer and of the overall basin and the overall basin hydrology. Now, to build that model, we looked at well logs and other hydrologic and geologic data, some of which are shown here on this slide as cross sections. And we needed to understand just some basic questions about the aquifer before we could build the computer model. How deep are the groundwater levels? Where do the wells generally pull their water from? How does the river interact with the aquifer through the basin? We ended up modeling two layers in the groundwater model, one for shallow unconsolidated sediments, and then a second deeper layer for fractured consolidated materials. Now, in reality, both of these geologic units can be highly productive for wells in the basin, and both of those units together form the overall useful aquifer. Now, once we built the computer model, and then we calibrated it to make sure that the predictions actually represent the real world, we finally were able to calculate the amount of groundwater flowing through the aquifer, and then that is what we use to feed into our mathematical model.
So as Chris said, we used a mass balance model to estimate the potential water quality degradation as a function of nitrogen loading from septic tanks. The mass balance model we used has been widely used in other septic system density studies by the Utah Geological Survey. The mass balance model we used is a mathematical equation, and it describes the relationship between the number of septic systems and the expected nitrate concentration in the aquifer. There's a linear relationship between these two, and as septic systems increase, so does the expected nitrate concentration in groundwater. This graph shows the existing nitrate concentration in our planning area, which is a little over 3 milligrams per liter. And our results indicate that the addition of approximately 1,000 septic systems in the planning area would result in a 1 milligram per liter increase in nitrate. The error bars represent a margin of error related to the uncertainty and the natural variability in some of the variables we used in the equation. And these are things like groundwater flow and the nitrogen loading per person.
So this mass balance model we developed serves as a tool to estimate that relationship between additional development and subsequent nitrate concentrations in groundwater. While the health department's able to manage future septic development, we also wanted to consider nitrate loading from centralized wastewater treatment, given that the sewer network in Wasatch County is expanding. Here we're simply comparing the loading that takes place from septic and sewer discharge of wastewater. The calculations or the numbers here are based on some standard values for septic systems and then data provided by the Heber Valley Special Service District. At the time of this study, the Jordanelle Special Service District was not online, and therefore we did not take that into account. Starting with septic, the discharge from a septic system is estimated to be about 63 milligrams per liter, which equates to roughly 17 to 22 grams of nitrate per person per day. The method of discharge is into a septic tank and out into a drain field into the soil, which has access eventually through percolation into the groundwater locally around each septic system. In contrast to the Heber Valley Special Service District, the discharges are estimated to be 5 milligrams per liter for effluent discharge through their rapid infiltration basin to about 16 milligrams per liter for the effluent that's discharged via land application to agricultural fields near the facility. And that equates to about 3 grams of nitrate per person per day. So the main distinction being that all of that effluent from a much larger population is being discharged in a couple of discrete locations. And really with water quality management, we're relying on dilution to maintain water quality. And therefore the density of septic systems is really important to ensure that there's enough aquifer flow and not too much effluent to impact that concentration of water quality locally. As the county continues to grow and that sewer network expands, the implications for potential degradation locally at these discharge points from the central wastewater treatment facilities, that increases. And as the county continues to grow, we're seeing more and higher density residential development that largely is being connected to that sewer network. This depiction is very generalized, but shows the various pathways of discharge of pollutants to surface and groundwaters. With this increase in residential growth, there's anticipated to be increase of types and quantity of potential discharge of pollutants, both the surface and groundwaters. Specifically, there's potential for a large increase in stormwater, and how that stormwater is managed and routed is really important in terms of how it may influence both surface and groundwater quality. The tools developed during this study have had a common goal, which is to help estimate changes in aquifer water quality due to the addition of additional discharge of pollutants such as nitrate into the groundwater. And a variety of regulatory approaches could be implemented to maintain and manage aquifer water quality. We weren't given specific guidance from the health department in terms of a target that they were looking to manage to or to manage below. And therefore, we came up with a few different recommendations that could be utilized in future management, starting with management by monitoring of nitrate concentrations. So using new and real-time information on the concentrations in the groundwater to determine future management or limits on growth. Continued management by limiting septic system density, or an approach of managing by limiting nitrate load. And a potential approach that would be a hybrid between setting a density regulation for septic systems, but making site-specific exceptions based on managing for load locally. And Tracy's going to tell us a little bit more about how the health department has used the results of this study in their management. But first, I'm going to summarize this study. I got ahead of myself here. For one, what we found with collecting this new information, doing our modeling, and developing these tools to inform management is that largely groundwater remains high in the aquifers. We feel that the current regulation, density regulation, has been protective, although we did identify localized hotspots where water quality degradation appears to be occurring faster. So this is really important to consider and may influence how specific locations are managed. And that we feel that there's several options for future management, and that this study has provided a baseline information, a body of knowledge that should be helpful in future monitoring and future management of the resource.
Thanks, Dave. As the Wasatch County Health Department, one of the major roles for us is to protect the groundwater resource that we have in the Heber Valley. And as has been talked about, we have high quality groundwater here. That's one of the specific goals of this study. Back in the 2000, the health department adopted rules regulating alternative septic systems. And a few years after that rule was adopted, we amended it to include allowing nitrogen reduction through treatment as part of the septic system process to address some of those density and water quality concerns. And over the past several years, we've seen an increase in demand of those types of systems. People are wanting to do more on smaller pieces of land. And it was evident that we needed to focus on some more specific requirements for the allowance of treating nitrogen and nitrogen reduction as a form of water quality management. And one of the primary intents of this study was to help inform that rule update and to provide more current data and recommendations. It had been several years, 20 plus years since the previous study, and we were making decisions based on that data. And we knew that we wanted to have more current data and more current recommendations, see what has happened over time, and to see if our current rule was adequate or not. And as we looked at the outcomes of the study, we went forward with updating that rule. And in October of 2020, the Board of Health adopted the updated rule to include some specific requirements for some of the non-residential, the multi-residential, and combined use systems. As we look at what those changes were, in the next slide, there was some base changes that we made based on the study. As Dave mentioned, the protection that we had of one septic system per 5 acres for new lots seemed to be working adequately. And so we've kept that minimum density But as far as some of the industry standard, as far as flow and the total nitrogen concentration, we did modify our existing rule to represent the 210 gallons per day at 63 milligrams per liter of total nitrogen. It was previously 400 gallons a day at 50 milligrams per liter. So we've used this updated information to help us in our calculations for nitrogen reduction. There are areas in our county where densities of less than 5 acres are allowed by the zoning ordinance. And so there's a conflict in places between the zoning ordinance and what water quality suggests we should do. And in those areas is where those nitrogen reduction technologies have been implemented, and we've allowed that to help protect the groundwater. We also put in a maximum reduction down to 20 milligrams per liter of total nitrogen. We have found over the last several years, as we've tried to go lower than that, and the technology to treat total nitrogen down to below 20 milligrams per liter has been a bit difficult. It's not been favorable. We've had some challenges in trying to hit some of those lower numbers. So with this updated rule, we've set the floor at 20 milligrams per liter. Also with that, if even with nitrogen reduction, the minimum number of acres that a new lot can have is 2 acres. And again, that's a function of that 63 milligrams per liter total nitrogen as a starting point, and the 20 milligrams per liter as the floor for that. And so any new lots that are created have to have a minimum of 2 acres with a nitrogen reduction down to 20. One of the other items in our rule that was a challenge for us in our old rule was the ability to issue operating permits and require maintenance and sampling. And so we added a more robust section in our rule to deal with that. The maintenance and the operation and sampling is a critical part to assuring that these systems are working adequately and protecting our groundwater. And there's also been a process that's been identified for non-compliance. What if the system stopped working, and is the first option to kick the individuals out of the home? We don't think so. There's some other things that can be done to try to address some of the non-compliance and exceedances, and we put that into the new and updated rule. So what's next for Wasatch County and the water quality and septic systems? Well, the first thing is we don't want to wait another 20 years until the information is updated. That was a real challenge for us. And so one of the things that we are trying to implement and identify is a plan to keep the study and the data relevant over time. We are going to identify periodic sampling analysis events at some interval, whether it be 2 years or 4 years or 5 years, and go back and monitor what our water quality is doing and not wait such a long period of time. We also want to try to anticipate what actions might be necessary if we start to see some of those parameters increase and the water quality degrade at a level that is concerning. We want to try to anticipate what actions could be taken. We recognize that water quality is affected by more than just septic systems. And we want to use this study also to help address other projects and issues that come about. And so I think as we look forward and anticipate what's happening within the Heber Valley, our citizens have good water and they want us to continue to protect that, so we continue to have good water. And that's kind of, again, our goal as the Wasatch County Health Department. Would really like to thank SWCA for their work on this project, for the information that we received, and thank you for letting us present this information to you as well.